Hi, and welcome to this NSE tutorial. My name is Richard Fien,
and today we're going through the setup of the position speed control mode.
Let's have a look at the setup we will be running in this tutorial. We have an NSE 5001-12 high temperature motor controller running firmware 308. This controller can be provided with either CAN bus interface or RS485. The protocol is more or less identical for the two interfaces, and this setup uses a 485 version. The controller is connected to a motor with resolver interface. The motor is mechanically connected to another motor that acts as a load. On the shaft connection there are indicators, so it will be easier to see the motor movement and steps. A separate video showing the shaft will be displayed in the lower left corner, and this will be synchronized to the commands we go through in the tutorial.
So first I'm going to start the node manager. The controller is connected with 485, this one. It's set up with the 375 kilobit bitrate, and we have enabled framing. So we press OK on that one. Just wait a little bit. The 485 takes a little bit longer than the CAN to come up. All right. So here we are on this one. Right now we're running a Maxon motor connected to a generator. You can see here we have a 25 volt input, and can have a look at how the controller is set up. So this is connected to the resolver motor. So we're running resolver freely oriented control. Then we're going to run position speed control. The motor is a one pole pair motor, so that's okay. And we have set up the resolver with the correct offset angle. So then what we're going to do in this tutorial is to see how we set up the control loop and how we tune the PI loop for this mode. So first thing I'm going to do, I'm just going to more or less zero out the PID parameters. So we can see if we can tune this in a good way. Right, and then what we will be interested in is to see how the RPM goes. And we're also going to be interested in the motor current. The first thing, let's have a look at how the control loop is set up. This is the position speed control loop. So this is what's integrated into the motor controller. And the inner loop is quite standard torque control loop. So you have a torque current and a flux current. So you want the flux current to be 0, but that's handled by the controller itself. And then you have a torque current. And here we have a torque current set point, which is the motor current. Then again, we have an outer loop here, which determines the maximum input current. So this is a little bit special for our controllers, but in many applications where they are being used, you want to limit the input current so that you're not exceeding the power of your power source. So let's say a 50 watt power source, and like now we have 25 volt. You don't want the input current to exceed 2 amp. Then again, this puts a limitation on the RPM. So what it means is that if the motor is spinning too fast, drawing too much current, this loop will actually put a limit on how quick the motor can spin. So ultimately, it's going to stall the motor if the motor is drawing too much current. Now, the best thing is, in order to prevent this from limiting the RPM, is to have the RPM set points and the torque set points set so that you don't exceed the power. But this can kind of be a last resort to prevent the motor controller from drawing too much power. So the middle position loop is actually a position control loop. What happens is that the motor controller itself will create position targets according to the set point to the set RPM. So the user only has to set a desired RPM, and then the motor controller will set the target accordingly. So that one will calculate how the motor controller should move in order to maintain the RPM. It also means that we get a position status output when we run in this mode. But this is the one we're gonna be concerned about tuning. Of course, the torque loop has to be set up properly as well. But we need this one set up so that you have a steady and good response on the RPM. So okay, I'm going to set the motor current to 5 amp. It's okay starting point. It's a little bit more than what I expect to draw, but then I don't get any limitation on the motor current. So the motor current is equivalent to the torque that the motor is providing. So it just means that, okay, we'll be allowed to go up to 5 amp. I don't expect to see that. We'll be allowed to go up to 5 amp. I don't expect to see that in this tuning though. Then I'm going to start with 1000 RPM. And I'm going to add a little bit of integral gain. Just go very slowly on the torque. So probably this is way too slow, but it's okay. Then, like I said, we don't want the input current to be limiting too much. So I'm going to set that up a little bit of integral gain on this one as well. And I'm just going to add a little bit of integral gain to the RPM set point as well. I will be surprised if this runs well, but let's see how it goes. Okay, so at least we see the motor is starting here. Okay. It wasn't the worst starting point. Now, if we want to see more in detail how steady the controller is, we can zoom in on the y-axis of the RPM. See, it's running quite nice. So actually, this was a better starting point than I could have wished for. Now, I want this though to be a bit more responsive. I want us to be able to accelerate much quicker than we did on this one. The first thing I'm going to do is I'm going to check what the ramp rates are set to. So these are internal slew rate limitations that are being used by the controller. So these are very useful to if you want the desired acceleration and deceleration whenever you change the RPM set points. So use these limitations to use these parameters to set up limitation for your acceleration and your deceleration. So in many applications, you don't want the motor to spin up quickly. That will usually make it draw lots of current. But in some maybe lighter applications, you want it to spin quickly, and this is what I want for this setup. But for other setups, you can use the this limitation to provide desired acceleration. But okay, right now I'm going to put this to 10,000, and also the acceleration to 10,000. So it means that it allows the controller to go from 0 to 10,000 RPM in 1 second. We see though that with these settings, we are nowhere close to that. It accelerates very slowly. The first thing is that it probably lacks torque. So it means that, okay, we have to increase the torque. I'm going to increase the torque interior gain and also the proportional gain. So let's see how that goes. Now considerably quicker on that one. Let's see if we can, sorry, this is the RPM loop. Let's see if we can add a little bit on this one. So hopefully by increasing these factors, the controller should reach its side RPM quicker. Still a bit slow. I'm gonna also increase that current limitation so that doesn't stop it. Now we could see it was spinning up much quicker. Just gonna keep on adding this one so it isn't limited by the input current. Now we see we got a very quick response on the RPM. I think we can see that sometimes it's probably overshooting a little bit. So it is maybe possible to adjust the proportional gain and the interior gain a little bit here, prevent the overshoot. But in general, it's kind of looking very good. It's spinning up really quickly here. See if we increase the starting. Now we see that we are limited by the input current because we're going so quick. Now we can see it's very responsive. We can see what happens if we change the ramp rates. Then we're gonna expect it to use 4 seconds accelerating up to 4,000 RPM. Then if we set it to 0, we use the same amount of time to go down to 0. Now we can see, okay, we can go the other way, set minus 4,000. And back to 0 again. We see now that, okay, if we go even slower, so let's make it really slow. Set it to 4,000. We see now that we have a steady acceleration at the set 200 RPM per second. That means it take approximately 20 seconds to reach the 4,000 RPM. I hope you enjoyed the tutorial, and contact us at NSE if you have any more questions about how to set up the controller or if there is any more guidance needed. Thank you.